Imagine a world in the mid-1800s where the sun setting meant your only source of light was a foul-smelling lamp filled with whale oil. This oil was dangerously expensive, and the massive demand for it was driving several whale species to the brink of extinction. But then, history took a surprising turn when a geologist named Abraham Gesner figured out how to extract a clear, clean-burning liquid from coal and oil. He called it kerosene, and practically overnight, this miracle liquid brought cheap light to the masses and quite literally saved the whales from total annihilation. This sudden availability of light did more than just brighten homes. It triggered a massive socio-economic revolution. Before kerosene, most human activity stopped at sundown. But cheap lamps allowed factories and small businesses to operate into the night, significantly boosting productivity. For the first time, students and workers from lower-income families could afford to study and read after dark, which played a crucial role in increasing literacy rates and accelerating the progress of the Industrial Revolution across the globe. To understand how we get this liquid, we start with crude oil, which is a chaotic soup of molecules called hydrocarbons. Kerosene sits in the middle of this family with chains containing between 10 and 16 carbon atoms. At a refinery, crude oil is blasted in a furnace to 400 degrees and fed into a towering fractional distillation column. As the vapor rises and cools, different hydrocarbons condense at different temperatures. Kerosene is collected in a specific zone between 150 degrees and 275 degrees, where it turns back into a clear liquid and is piped out. However, raw kerosene contains impurities like sulfur that would create toxic smoke if burned immediately. To fix this, it undergoes a process called hydrotreating, where it is mixed with hydrogen gas under high pressure and heat to strip away the sulfur. This results in a liquid that is so stable and energy-dense that we now use it as the primary ingredient in jet fuel. It allows massive airliners to fly at 35,000 feet without freezing, and even powers the rockets that carry humanity into space. While kerosene once saved the whales and revolutionized our cities, its modern use in aviation presents new environmental challenges. As a fossil fuel, it contributes to carbon emissions and climate change, leading scientists to search for the next big breakthrough. Today, researchers are working on sustainable aviation fuels and biokerosene, aiming to maintain our global connectivity without harming the planet. Just as kerosene replaced whale oil in the 19th century, the next evolution of this simple liquid is already being engineered to power a cleaner future. From a humble lamp to the roaring engines of modern aviation, kerosene has been a silent partner in human progress. It is a simple liquid separated by heat, yet it completely transformed the way we light up the night and travel the globe.